So let's continue with kinematics as we begin to look at motion in two dimensions under a constant force. So motion in two dimensions under a constant force is also referred to as projectile motion. Why is it referred to as projectile motion? It's simply because the particle is not affected by driving force. The only force affecting the motion of the particle, they are the what? External forces. So the particle moves freely in air. Okay, we will get into that. That's why we say that the force affecting the motion of the particle is constant. And that is the force of gravity. So if the motion of the particle is moving freely in air, under the influence of only the force of gravity, we can classify that motion is said to be a projectile motion. So what explains it to be motion in two dimensions? If, for example, a car moves on the horizontal road, the motion of that particle in that case is in how many dimensions? It is in one dimension. If a particle is projected vertically upwards, the motion of that particle in that case is in how many dimensions? It's in one dimension. The motion is only along the vertical. So the components of this motion will be described in terms of the component of the motion only along the vertical. In this case, the component of the motion will be described only in terms of the component of the motion along the horizontal. What if a particle like a ball is kicked and it follows the path of a parabola? As the ball moves forward, it also moves upwards. So the motion of this ball in this case is said to be in two dimensions because it's covering motion along the horizontal and along the vertical at the same time. The particle moves upward, the particle also moves what? Forward. So the motion of the particle in that case is said to be in two dimensions. So what are the forces affecting the motion of this particle? We have the force of gravity, which is the weight. So weight acts vertically what? Downwards. As the particle is moving upward, it will be experiencing resistive force downwards. As the particle also moves to the right, it will be experiencing resistive force to the left. So the forces affecting the motion of the particle is basically the weight and the resistive force, which in this case, it is air resistance. So in order to know the acceleration of the particle in any direction, we have to look at the resultant force producing the acceleration in that direction. So let's look at acceleration along the vertical. Acceleration along the vertical. So what are the forces affecting the motion of the particle along the vertical? We have the weight acting vertically downwards, the particle is moving upwards. Drag force acting vertically downwards, the particle is moving upwards is equal to what? Ma. So the acceleration along the vertical, let me call the vertical the y-axis, horizontal the x-axis. So A substitute y means acceleration along the vertical. If you divide this through by m, you are going to have minus g minus d over m. So the acceleration along the vertical becomes minus into g plus d over m, which is the acceleration of the particle along the vertical. Then also acceleration along the horizontal. Acceleration along the horizontal is only, the particle is only affected by the resistive force there. So the resistive force minus d is equal to what? Me. As the particle moves to the right, it's experiencing resistive force to the left. Therefore, acceleration along the horizontal becomes minus d over m, which is the acceleration due to the what? Resistive force. Now, in this motion, we have to consider that air resistance is negligible. So if air resistance is negligible, then the particle will be experiencing, the particle is moving under a constant force. That means that the drag force here becomes equal to 0. So the acceleration along the vertical becomes minus g, while the acceleration along the horizontal is equal to 0 if air resistance is negligible. So if air resistance is negligible, you have to take the acceleration along the vertical to be minus g and acceleration along the horizontal to be equal to what? 0. So the next thing we should look at the velocity of the motion. The velocity. The velocity is directed at a tangent to the parabola. So at the point of projection, the velocity is directed at the tangent to the parabola. Let's call it u. So for this case now, the velocity at the point of projection is in 2 dimensions, and it is inclined at an angle of theta to the horizontal. So the component of the velocity along the vertical will be, let me use this, the component of velocity along the vertical there will be u subscript y, while the component of the velocity along the horizontal will be u subscript x. So if I resolve the velocity of projection, which is in 2 dimensions along the vertical, u along the vertical becomes u sine theta, while the component of velocity along the horizontal becomes what? U cos theta. If the particle gets to this point, for example, the velocity is still in 2 dimensions there. The velocity here is v, the velocity along the x, and the velocity along the y. Let's call this one, the direction is now what? Alpha. So the velocity along the y, in that case will be what? V sine alpha, while the velocity along the x becomes what? V cos alpha. And you know that the magnitude of the resonant velocity v will be square root of the velocity along the y squared plus the velocity along the what? X squared. And the direction of that velocity, tan alpha, will be equal to what? The vertical velocity over the what? Horizontal velocity. Is that okay? Now when the particle gets to the maximum height, somewhere here, the direction of the tangent is now horizontal. So at this point, the velocity is only along the horizontal. The vertical velocity at this point is equal to 0. So I can say that at maximum height, the vertical velocity is equal to 0. The velocity of the particle is only in 1 dimension, which is along the horizontal. Okay? So, this is very important. So, if you are asked to find, for example, the time taken for the particle to reach the maximum height, that will just be the time taken for the vertical velocity to be equal to 0. If you are asked to find, for example, the maximum height, that at the maximum height, the vertical velocity is equal to what? 0. So let's look at the displacement. The displacement OP. Let's say the particle is projected at point O, is now at point P. The displacement OP is a straight line. Between the point of projection. Between the point of projection to the point where the particle is. To the point where the particle is. So I have displacement OP like this. Okay? That displacement, so at that particular point, the particle will have covered both a vertical height h as well as horizontal distance x. These two displacements are perpendicular to each other. So if you look at this, it forms a right angle triangle. So I can say that OP, which is the displacement, will be equal to square root of what? That represents the hypotenuse. These are the two adjacent sides. H squared plus what? X squared. So we have described the displacement of the particle. We described the velocity. We have also described the what? Acceleration. So how do we then describe the motion of the particle? Because we have known some specific things we need to know. How do we then use the equations of motion to describe the motion of the particle at a given time or at a given position? So we can therefore use the equations of motion now. So in order to do that, let's look at the equations of the motion. So equations of motion. Equations describing the motion. Look, I can write it here. Equations describing the motion. So the equation that is describing this motion will be the equation that is describing this motion along the vertical and the equation describing this motion along the horizontal. To be the equation that describes this motion along the vertical and the equation that describes this motion along the what? Horizontal. So we have, remember the equation of motion I've given you before. We have v is equal to u plus at, s is equal to ut plus what? Half at squared. V squared equals u squared plus 2as. S equal to vt minus what? Half gt squared. Okay. So then of course we also have s is equal to half u plus v times t. What we now want to do is to use this equation to describe the motion of the particle along the horizontal and the motion of the particle along the vertical. What that simply means, we are using this equation to describe the motion of the particle along the y and the motion of the particle along the x. So don't forget that, so I can clean this. This is just a reminder. So describing the motion of the particle. Now using the first one, using the equation v is equal to u plus at. This equation is the equation that describes how velocity is changing with time at a constant acceleration. So the vertical velocity at time t will be equal to the vertical component of the initial velocity. Acceleration along the vertical is minus g. So I have vy minus what? gt. Then the horizontal velocity at time t will be equal to what? Horizontal component or the velocity of projection plus at. But you know that acceleration along the horizontal is 0. So vx is equal to ux. That means along the horizontal, the velocity is constant. So I can write this as vy is equal to u sine theta. We have already said that. That is uy minus gt. While here, vx is just equal to what? U cos theta. Then the next one, using the equation, s is equal to ut plus half at squared. This equation describes the distance or the displacement of the particle at a given time under a constant acceleration. So at a given time, the particle will have covered both vertical displacement, which is h. So to find the vertical displacement h, I have to use the component of the motion along the vertical. So this u will be what? Vertical component of the velocity of projection times t. Acceleration along the vertical is minus g. So this becomes minus half gt squared. So I can say that this is h is equal to what? Okay, let me make space. So I can say this is h. The vertical displacement is h. So to find the vertical displacement, we'll use the component of the motion along the vertical. So this becomes uyt minus what? Half gt squared. So this can be written as h becomes what? U sine theta minus what? Half gt squared. So I have described the vertical displacement using the component of the motion along the vertical. Vertical component of velocity of projection, the vertical acceleration, is minus g. Then also describing the horizontal distance x. This will be what? uxt. Don't forget that acceleration along the horizontal is 0. So I can say that horizontal displacement x will be given as what? U cos theta times t. Then the third one, I can also use this using the equation v squared is equal to u squared plus 2as. So this equation describes the velocity changing with position at a constant acceleration. So the vertical velocity at a given vertical displacement h will be given as vy squared is equal to what? Uy squared minus 2gh. So the vertical velocity at a given height will be given as what? U sine theta all squared minus 2gh. While the horizontal velocity vx squared becomes what? Ux squared. Square cancels square. So we can just say that Vx is equal to Ux, which is equal to what? U cos theta. That basically tells us that the velocity along the horizontal is not changing. Because we are saying that along the horizontal there is no acceleration. So the velocity along the horizontal is not changing. The velocity is constant along the what? Horizontal. The only instance where the velocity is changing is the velocity changing along the what? Along the vertical. Alright, so let's brood over this. Let's spend some time to brood over this. Because when you brood over an information, it becomes deeper inside of you. So what we are explaining here is this. You do not need to cram the equation of motion to describe the projectile motion. What you need to do is to separate the motion to the vertical and also separate the motion to the horizontal. And use the component of the motion in a given direction to describe the motion. So if I want to look at the vertical velocity at time t, I'm using it. Horizontal velocity at time t, velocity along the horizontal is changing. If I want to find the height of the particle at time t, is vertical, I will use this. The displacement of the particle at time t, I will use this. Horizontal displacement at time t. So if I now want to find the resultant displacement OP, that will be given as square root of x squared plus 1x squared. You find your h and your x squared here. Then the vertical velocity at the given position s will be given as what? Vy squared equal to uy squared minus what? 2gh. That becomes this. Okay? So what can we learn further from this? If, for example, you are asked to find the time taken for the particle to reach the maximum height, I will just say that at the maximum height, Vy is equal to 0. Therefore, the time taken for the particle to reach the maximum height is the time for Vy to be equal to 0. So I'm going to have 0 is equal to u sine theta minus gt. Therefore, gt is equal to u sine theta, and t will be equal to u sine theta over g, which is the time taken for the particle to reach the maximum height. So those are deductions. Those are deductions. Then the time of flight, if the motion is symmetric, meaning that the time taken for the particle to return to the level of projection will be twice the time taken for the particle to reach the maximum height. So what does that mean? Vy is equal to 0 there. T will be equal to what? U sine theta over g, which is the time taken to reach the maximum height. So the time taken to now move from maximum height back to the level of projection, T will now be equal to twice 2 times u sine theta over g, which is 2 u sine theta over g. If I don't want to do that, I want to find the time taken for a particle is projected, it follows the path of a projector. Time taken for the particle to return to the level of projection. When the particle returns to the level of projection, h is equal to 0. So I'm going to have r gt squared is equal to u sine theta times t. T will take t. Okay? So t will now become what? 2 u sine theta over g. You can try that yourself. This one also, if I want to find the vertical height here, the maximum height, I mean, this is for any given height, but maximum height means that Vy is equal to 0. So 2gh is equal to u sine theta all squared. So h becomes what? U sine theta all squared over 2g, which is u squared sine squared theta over 2g, maximum height. So we have explained it in the generic sense. You can also be able to extend it to look at the different aspects you need to look into. Is that okay? Now, let's take let's just take a question here. Let's take a question here. Let's take a question. So you can write whatever you need to write down, or you can pause it and write it down. So question. A particle is projected at a velocity of 5 meters per second at 30 degrees above the horizontal. As shown below. At 30 degrees above the horizontal as shown below. Okay? Full stop. Air resistance is negligible. The particle strikes a wall. The particle strikes a wall at time t equals 0.25 seconds. The particle strikes the top of a wall at time of 0.25 seconds. Calculate 1. The height of the wall. Ri, the horizontal displacement of the ball at that instance. The horizontal displacement of the ball at that instance. Then the next one, the velocity of the particle at that instance. The magnitude of the resultant velocity at that time. Then also